This is SqueezeSeg, a convolutional neural network for segmentation from LiDAR point clouds. We'll demonstrate real-time inference speeds and strong qualitative results. First, what is our task? We're given point clouds generated by LiDAR that uses lasers to measure distances to obstacles in the environment, and our task is to use neural networks to detect objects of interest. Specifically, we wish to identify points that belong to each instance of a pedestrian, car, etc. Below is a video for reference. This is our data, but how do we pass point clouds to neural networks? On the bottom left, we again have our point cloud. We choose to project all our points onto a 2D spherical surface. Using this spherical projection, we then get a set of 2D channels that maintain structural information present in our original RGB image. We have our data, but now let's consider the neural network architecture. We need real-time inference, and to do that, we use a convolutional neural network with a few tricks. To downsample, we use the fire module, a combination of 1x1 and 3x3 filters. To the right, we have our 1x1 squeeze layer at the top level. Below that is our expand layer. To the bottom left, we see drastic reductions in the number of parameters and units of computation for a fire module as opposed to a traditional convolutional layer. To upsample, we use the fire deconv. To the right, we again have our squeeze and expand layers. Here, we introduce a deconv layer to upsample our inputs. Again, we see drastic reductions in both the number of parameters and units of computation. To finish it off, we use a recurrent conditional random field layer to refine results, introducing finer granularities of detail. We now have a method, but how do we obtain training data for the network? We consider data from two different sources. The first is the KITTI dataset. We use provided 3D bounding boxes to label KITTI's point clouds, giving us approximately 10,000 samples. We additionally use GTA5. Here, we built in a LiDAR simulator to generate 8,000 more samples, doubling the size of our training set. Using both synthesized and KITTI data, we're able to achieve high accuracy with qualitatively strong results shown here. Here's the same drive shown from a different perspective. Finally, can this run in real time? As it turns out, yes. First, note the inference time per frame. With SqueezeSeg, we attain from 70 to over 110 frames per second, 2 to 3 times faster than the camera's real-time frame rate. This is SqueezeSeg, a convolutional neural network with real-time inference speeds. Thank you.